Very good evening, one and all. So, in this lecture, what I am going to discuss with you is the piezoelectric sensor. So, we know what is meant by piezoelectricity, isn't it? Or what is meant by a piezoelectric material. So, that is the main principle behind a piezoelectric sensor. So, actually, this piezoelectric sensor, which can be used for measurement of pressure, force, acceleration, etc. So you, with the help of piezoelectric sensor, you can measure this. Now, what is the basic principle of a piezoelectric sensor, or what is a piezoelectricity? We know that the piezoelectric materials, when it is stretched or when it is compressed, they generate electric charges with one phase of the material become positively charged and the opposite phase become negatively charged. You can see that in the top figure. When subjected to an external pressure, a force, one side you can see the positive charges and on the other side you can see the negative charges. Surface becomes charged. So what will be the end result? As a result, a voltage is produced. Now basically these piezoelectric materials, they are nothing but they are ionic crystals. And as a result of stretching or compression, they result in the charge distribution in the crystal, so that there is a net displacement of charge with one phase of the material become positively charged and the other become negatively charged. So I can tell you, so this is actually the principle how the piezoelectric sensors work. Okay, there will be a net potential difference because of the charge separation. So for example, so I can tell you the net charge Q on the surface. The net charge Q on the surface is proportional to the amount x by which the charge have been displaced. Okay, which means I can write here an expression q, I mean q is equal to an expression a small k into x, which means here k is a constant and s is a constant termed as the charge sensitivity. For different piezoelectric materials, the value S. So I can write Q is equal to Kx, which is equal to S into F. Okay. So I told you the net charge Q on the surface for when the piezoelectric material is stretched or compressed, the net charge Q on the surface is proportional to the amount X by which the charge have been displaced. And also the displacement is proportional to the applied force. So Q is equal to Kx is equal to S into F. S is a constant termed as charge sensitivity. F is nothing but the applied force. So Q is equal to Kx is equal to SF. So this charge sensitivity S, so that value depends upon the material concerned. Which type of piezoelectric material? For example, the commonly known piezoelectric material is quartz. Its charge sensitivity value is 2.2 Pc bar N. P small p capital C per N. So what does it mean? The unit mean is nothing but the pi coulomb per Newton. And if it is if you are going to use the barium titanate as a piezoelectric material, its value is 130, and for the lead zirconate titanate, it is about 265. So depending upon the different type of material, the charge sensitivity value varies. And what is shown below is a piezoelectric capacitor. So if you look at the diagram, you can see that the metal electrodes are deposited on opposite faces of the piezoelectric crystal. And here also the capacitance of the piezoelectric material between the plates, you can easily write down, that is capital C is equal to epsilon 0 epsilon r into A by T, where epsilon r is the relative permittivity of the material, A is the area, and T is the thickness. Okay, I mean the thickness of the between the two capacitor plates. So that's all about. Thank you.